Welcome into Lesson 8. Today we're diving into the numbers behind the nutrition because good clinical practice depends on good math. In this lesson, we'll calculate ideal body weight, estimate energy requirements, and look at how to assess nutrient intake. We'll get started with the ideal body mass. This is our starting point for many nutrition assessments, especially when we're calculating energy needs using formulas like kcal per kilogram. Ideal body mass is an estimate of what someone should weigh based on their height, biological sex, and frame size. Not what they currently weigh, but what would be considered a healthy baseline under typical conditions. I have thoughts about this calculation, but it could be on the RD exam, so let's make sure you get them right. The formula is worth some brain space, and I would definitely recommend you memorize it. But it isn't that hard, I promise. For men, we start with 106 pounds. We add 6 pounds for every inch that man is over 5 feet, and if they're under 5 feet tall, we subtract 6 pounds per inch. So it's plus or minus 6 pounds for every inch. For women, the pattern is similar. We start with 100 pounds as our baseline and add in 5 pounds for every inch over 5 feet, or we subtract 5 pounds for every inch under 5 feet. That's it. Since men tend to have more muscle mass, they get 106 pounds for being 5 feet tall, where women, quote unquote, ideally are 100 pounds at 5 feet. Any taller, and you add 6 pounds per inch for men and 5 pounds per women. Less than 5 feet tall, and you subtract. But obviously, height alone doesn't capture everything. Think about two people who are both 5 foot 10 inches tall. One might have a lean, narrow build, while the other has a broader, more muscular frame, like a runner and a rugby player. We can adjust ideal body mass based on their frame size. Increase that number up by 10% for someone with a large frame, and take it down by 10% with someone with a smaller frame. These adjustments help tailor the weight range to the individual somewhat. Is it a perfect science? Definitely not. But it's a standardized way to estimate an appropriate weight. And if a patient's current weight isn't available or reliable, like in some clinical care settings, ideal body weight can serve a vital role. And we can add in other layers of complexity. What happens when someone has an amputation or a spinal cord injury? These conditions can significantly alter body composition, so we can adjust the ideal body mass to reflect that. Each limb contributes a different proportion to a person's total weight. For example, if someone has lost an entire arm, we would deduct about 5% from their total body mass. Just their lower arm, about half of their entire arm, is about 2.3%. Frankly, I think of the arm as 5%, so half of that for half the arm is 2.5%. But since the lower arm is smaller than the upper arm, it's slightly less than 2.5%. And if someone has lost their entire leg, that's a much bigger change, about 16%. And a lower leg amputation is, again, about half of that, remembering that the lower leg is the smaller half of the leg. So a lower leg amputation is removing roughly 6% from your ideal body mass calculation. We subtract these percentages from the ideal body mass because using the unadjusted weight would lead us to overestimate their nutritional needs. And we can also think about spinal cord injuries. Individuals with quadriplegia, those who are bound to a wheelchair and cannot move their hands or legs, often lose a significant amount of muscle mass. So we would reduce their ideal body mass by about 10%. For paraplegics, the reduction is typically between 5 and 10%, depending on the extent of the immobilization. These aren't arbitrary numbers. They're based on changes in metabolism, body composition, and functional muscle loss. Adjusting for these differences help us avoid overfeeding and better match nutrition support to true physiological needs. Let's put it into practice with an example. Imagine a male patient who stands 190 centimeters tall and has a large frame. Pause this video and try to calculate his ideal body weight. Well, we remember the equation for ideal body weight for men is 106 pounds, and then we add in 6 pounds for every inch over 5 feet. This man has a large frame, so we can add 10% to that for his ideal body weight. But we have his height in centimeters, and this equation has it in inches. So what we need to do is convert centimeters into inches. To do that, we'll need to use our equivalent statement that relates inches to centimeters. Every 1 inch has 2.54 centimeters. So if this man is 190 centimeters, we can convert that into inches. Since the given is in centimeters, we'll put centimeters in the denominator so that they cancel out. Since 1 inch is equal to 2.54 centimeters, 2.54 centimeters is on the bottom, which tells us that 190 centimeters is equal to 74.8 inches. So how many feet tall is that, right? We need to know compared to his height based on 5 feet. So we actually need to convert 78 inches into feet. And there's another equivalent statement here that you need to know, that there's 12 inches in every 1 foot. Since we want to compare 5 feet into inches, I converted 5 feet into inches. But you also could take 74.8 inches and convert that into feet and see how much taller he is than 5 feet and convert that remaining decimal into inches. But I took my 5 feet and converted it into inches. 5 feet is 60 inches. And this man is 74.8 inches. So he has an additional 14 inches on top of his 5 feet. So he's really 6 feet, 2.8 inches tall. But now we know that he's 14.8 inches taller than 5 feet. So we can plug into our equation. Remember, it's 106 pounds plus 6 pounds for every inch over 5 feet. So if we take 106 and add it to the product of 6 times 14.8, we get 194.8 pounds. That's his ideal body weight. Oh, but don't forget, he's got a large frame. So since he has a large frame, we'll need to use this 10% here. 194.8 pounds is the standard, but since he has a large frame, we can estimate an additional 10% more. You know I like to multiply by 1.10, which is really just saying 100% of 194.8 is 194.8, but he's 10% more. So he's 110%, which is 110 over 100, which is 1.10. So his adjusted ideal body weight is 214.28 pounds. Let's try another one. In this problem, we have a 30-year-old patient who is 66 inches tall and she has paraplegia. We want to calculate her ideal body weight. Definitely pause this one and try it on your own, because I'll be there for you all the time, except on the RD exam. That's when I won't be there. So the equation for women, we take 100 pounds and we add 5 pounds for every inch over 5 feet tall. And since she has paraplegia, we're going to subtract somewhere between 5 and 10%. Since we know she's 66 inches tall and we need to compare her height to 5 feet, I again would want to convert 5 feet into inches and see how many inches that is. Well, we know there's 12 inches in a foot, so feet cancel out, and we find out 5 feet is 60 inches. We actually had the same calculation up on the last slide. And this woman is 66 inches tall. Since she's 66 inches tall, that's 6 inches over 5 feet. So this woman is 5 feet, 6 inches tall. We can use the equation for ideal body mass, which says you take 100 pounds and you add 5 pounds for every inch over 5 feet tall. And she's got 6 inches over 5 feet tall. So ideally, she would be 130 pounds. But since this person has paraplegia, we would subtract somewhere between 5 and 10%, subtracting 5%. So 100% would be exactly 130 pounds, but we want 5% less than this. So we're talking 95% here. And if we're subtracting 10%, then we're looking at 90%. 90% means 90 over 100, which is 0.9, and 95% means 95 over 100, so 0.95. If we take 130 and multiply it by these percent calculations, then we can find out that her ideal body range would be somewhere between 117 and 123.5 pounds. This is not the only way to do this problem. You could also multiply 130 pounds by 0.05, that's 5%, up to 10%, and find out how much to subtract from 130 pounds. But you're going to get the same answer. Remember, on your exam, there is no partial credit. Whatever method gets you to the right answer is the method you should choose.